Today's lesson: irregularity in electron affinity. What is the irregularity and what is the reason behind this? In this lesson, we are going to learn this matter. So, let us get started. Let us take a column of periodic table in which there is irregularity in electron affinity. The column is 17th column. Elements of 17th column are fluorine, chlorine, bromine, iodine, astatine, tennessine. Elements of column 17th. We know atomic sizes along a column from top to bottom increase. The matter is like this: fluorine, which is smaller in size, chlorine, which is a bit bigger in size than fluorine, then bromine, which is more bigger than iodine, which is bigger in size than bromine. Bromine is bigger in size than chlorine. Chlorine is bigger in size than fluorine. That is, from top to bottom along any column in the periodic table, atomic sizes increase. Now let's try to recall what is electron affinity. Suppose this is an atom and this is its outermost shell. Here, this is incoming electron from another atom which is negatively charged. Here, this nucleus attracts this incoming electron. Electron affinity is when this electron is added to the outermost shell of this atom, then some amount of energy is released. That energy which is released from this process, then this energy is called electron affinity. Energy of electron affinity. This energy, amount of energy, depends on the distance of these nucleus and incoming electron. If the distance is less, then attraction is more and amount of energy released will be more. Suppose this is another atom which is a bit bigger in size. Here this is incoming electron. When this electron is added here in the outermost shell of this atom, then some amount of energy is released which is known as electron affinity. This energy which is released from this process, this energy is known as electron affinity. Here the distance is more than this atom, that is a smaller atom. Here more distance, less attraction. Less attraction, amount of energy released will be less. That is, smaller atom, short distance, more attraction, amount of energy released will be higher. More distance, less attraction, amount of energy released will be lower. That is, electron affinity depends on the size of atom. Simply we can say that the smaller the atom, the more the electron affinity. From this concept we can say that electron affinity series should be fluorine first, then chlorine, then bromine, and then iodine, because fluorine is smaller and then atomic sizes increase up to iodine. So electron affinity of fluorine should be higher, then chlorine, then bromine, and then iodine. It should be the series of electron affinity. But actually, electron affinity of chlorine is 349 kilojoule per mole. This is a kind of exothermic process. That is why minus sign is used. Electron affinity of fluorine is 328 kilojoule per mole. Electron affinity of bromine is minus 325 kilojoule per mole. Iodine minus 295 kilojoule per mole. That is electron affinity series of halogens. Actually, chlorine first, then fluorine, then bromine, and after that iodine. What is the reason behind this? Let's try to find this matter. Let's try to see what is the reason behind this. That is, electron affinity series should be this, but this is not the series actually. Actually, electron affinity series is this. That is, electron affinity of chlorine is higher, then fluorine, then bromine, and then iodine. Let's see the reason. Here, let us consider this is chlorine and then fluorine, which is smaller in size. Now let's see electronic configuration of chlorine: 1s2, 2s2, 2p6, 3s2, 3p5. That is, outermost shell of chlorine contains total 7 electrons. Here, let us see these 7 electrons. Here, one unpaired electron. Electronic configuration of fluorine is 1s2, 2s2, 2p5. That is, outermost shell, second shell contains 7 electrons. Here, let us consider these 7 electrons. In case of chlorine, outermost shell, third shell contains 7 electrons. But in case of fluorine, second shell contains 7 electrons. Second shell radius is lower than chlorine. So here, in case of fluorine, electronic density is higher because smaller atom contains 7 electrons, but this one bigger atom contains 7 electrons. So here electron density is higher than chlorine. That is why accommodation of another electron in case of fluorine becomes tough than chlorine, because in case of chlorine electron density is comparatively lower than fluorine. So why electron affinity of fluorine is lower? Fluorine is smaller in size. Its outermost shell, second shell, contains 7 electrons. Here already electron density is very high. That is why accommodation of another electron becomes tough. That is why this attraction between nucleus and incoming electron is less less attraction, electron affinity is less. But here, though distance is higher, but addition of this electron is a bit easier than fluorine. That is why this nucleus can attract this electron with high affinity, that is high attraction, high electron affinity. So though fluorine is smaller in size because of the high electron density in its outermost shell, electron affinity of fluorine is lower than chlorine because chlorine is a bit bigger in size than fluorine, and for this, in the outermost shell of chlorine, electron density is a bit lower than fluorine. Because of this electron density in the outermost shell, electron affinity of fluorine is lower than chlorine. Simply, we can say that electron affinity of fluorine is lower than chlorine because fluorine is smaller in size, electron density in its outermost shell is higher, accommodation of another extra electron is a bit tough. That is why attraction between nucleus and incoming electron is lower, electron affinity is lower. But in case of chlorine, electron density is lower than fluorine, attraction between incoming electron and nucleus is higher, electron affinity is higher. This is all about irregularity in electron affinity. No more today. Thank you very much.